Hello there, 10th graders. This is Teacher Krishna, and welcome to our physics class for week number 17. Thank you a lot for coming to today's lesson and, of course, for completing the assignments that we will have later on. Before we start, just like every week, log into Agilex, enter the Google Classroom, download your Word document, save it in your physics folder, and, of course, name it as it is specified right below. As we move, remember to take notes on the Word document. That is extremely necessary so you can keep track of the most essential things from this video and PowerPoint presentation. It is crucial that we start with our end in mind, and for topic 2.10 is the following. Students will be able to successfully complete free-fall problems by critically analyzing the givens from several problems and the relationship among them. Make sure to keep track of the end in mind in your Word document before we continue. Alright, so this is an example of the application of the topic that we're going to be learning about today. So the topic we are going to learn about today is free fall motion. So an object experiments free fall when gravity is the only force that affects it. This is something a little bit hard to get in some materials because there are different mediums and elements around the environment that are going to affect their fall. Okay? So fluid friction is the resistance that objects experiment when they are in contact with a fluid. The most common fluids that you are going to find around you are air and water. I can give you one clear example. So if you grab a piece of paper and you place it in a horizontal position and you simply let it go to the ground, then you will notice that it will somehow swing. So it will go left, it will go right, left, right until it reaches the ground. But if you take exactly the same piece of paper and then you turn it into a ball of paper and you let it go to the ground, you will analyze that it goes faster than what it did before when it was just in like a normal piece of paper. What happens is that the piece of paper is experimented fluid friction. So depending on the shape that it has, it will experiment more or less fluid friction. So when the piece of paper is flattened, then it experiments more air friction, and that is why it somehow starts to swing. And it lasts way longer to reach the ground. But what happens with the ball? Then it does not experiment as much fluid friction as when it was flattened. This is an example of the application of this term specifically. And this can be taken away from certain objects. So, one more time, it depends on what object you are analyzing and their shape, of course, as well. Because all objects have the same attraction of gravity to the ground, but depending on their, how do you call this one? Depending on their characteristics, they will experiment more or less fluid friction. Now we have some very important terms. We have gravity, which is an attractive force that affects any object with mass. Gravity is an interesting term to analyze because usually we think that gravity is only found in planets, just like Earth or Mars. Even stars have gravity. But what happens is that not only these huge um, bodies have gravity. Let's suppose that you go to space. So once you are out of the planet, then your body and all the objects around you are going to experiment something that is named a microgravity, which means that your body, because of the mass that it has, is going to attract other objects with mass. That is why if you put some water in your hand, most likely it is going to stick to it in outer space. So gravity, of course, is found in stars, in planets, but it is found in other smaller bodies, such as humans when they go to space, of course. Now we have free fall. Free fall objects do not experience air resistance. Remember, if you really want to analyze a problem that has free fall, then the object does not have to experience air resistance or fluid resistance. All free-falling objects accelerate downwards at a constant of 9.8 meters per second square. So this is a very important value that we are going to be using in many problems later on in physics. So try to memorize it already. So the value for gravity, or how much an object accelerates downwards, it is a constant of 9.8 or 9.81 meters per second square. All right. In some cases of application, we are going to be using this value as 10 meters per second square. So it is a little bit easier to explain some concepts, all right? But regularly we use 9.8 or 9.81. We have mass. What is mass? It is the amount of matter in an object. And what is weight? Weight is a measure of gravitational attraction of an object. So mass is something that is always going to be constant in an object. For example, 10 kilograms or 20 kilograms. But weight, the weight will be affected depending on the gravitational force that is applied to that specific object. For example, your weight is not going to be the same in Earth than in outer space. Or your weight is not going to be the same as if you are in the moon. So that is why we have the relation between mass and weight, because they both can be different, or most likely weight can be different depending in where you are. And now we're going to talk about Galileo, and he found that speed acquired. I'm sorry, it should be. He found that speed acquired at the same rate without their weight mattering at all. So what this means is that the gravity is not changed, and the force of attraction is not changed either. For example, what I told you about the paper regarding their shape, of course. So when you have two pieces of paper, and one is flattened and the other one is a ball of paper, and you drop them at the same time, the ball is going to reach the ground first, and the other flattened paper is going to reach the ground later on. But keep in mind that they both have the same mass, and they both have the same weight because we are applying it in basically the same planet, of course. So what happens is that the force of attraction is exactly the same. So how is it possible if they have the same mass, same weight, they are having the same force of attraction towards the ground, which is gravity? How is it possible that one of them reaches the ground first than the other? Well, it is explained by what we mentioned before, which is the fluid friction. So air resistance is something that actually influences the attraction of objects to the ground. And that was something that Galileo was studying. And curious fact, a lot of people, especially religious people from the Catholic Church, they wanted to kill Galileo because of his experiments. So, a lot of years ago, any scientist will be considered a magician, or he will be considered as someone that had a pact with the devil. So Galileo was very close to get killed from the Catholic Church because of his experiments. Not only these experiments related to gravity, but also related to astronomy and many other sciences. Alright, now we're going to talk about Newton's discoveries. The intensity of gravity is inversely proportional to the square of the distance of two objects. So, well, this specific state sounds very complicated, but it is not. We are going to analyze it in a little while, okay? Here you go. Here you have one application. So, first of all, we have an action. Let's start with the first one. It says double the distance. Okay. So now, and when we mention that something is inverse, it means that you are going to change its position. So I'm presenting this in very simple terms so that everybody can understand it. But basically, let's imagine that you have a division. You have numbers at the top and you have numbers at the bottom. Okay. So if you are going to inverse number 2, then you are going to put number 2 from the top to the bottom of the division. All right. So now your 2, when you inverse it, will become 1/2. All right. And if we go back to the state one more time. So the intensity of gravity is inversely proportional. So now we already have the inverse because we already turned our 2 to 1/2 to the square of the distance. Okay, so that means that the inverses that we have right here, we have to take it to the second power. Okay. So in this case, if we elevate 1/2 to the second power, we are going to get 1/4. And the intensity will be, of course, the result of the square that we did previously. So the result will be 1/4 times as strong. The same thing happens if we analyze the second problem in triple the distance. So we have a number 3. When we inverse it, we have 1/3. And if we square 1/3, we have 1/9. And of course, our intensity will be 1/9 times as strong. All right, but now what happens if we have a fraction already at the start? A quarter the distance, so we have 1/4. Right, so now we're going to do the opposite. We are not going to take a number 4 from the top to the bottom, but we are going to take it from the bottom to the top. Okay, so basically, if you have 1/4 and you take a fourth above, then you will stay with a number 4. Now, we have to square it, so 4 squared will be 16, and the intensity will be 16 times as strong. So, sometimes you are going to find like very complicated terms, just like the ones that are presented in here. But once you analyze them, you can notice that they are pretty easy to understand and to apply, just like it's here. Like you inverse it at first, or you change its position from top to the bottom or bottom to the top. You square the result of the inversion and you get the intensity. Chanan! I know it's a little bit difficult to understand at first, but that is why I'm here, to help you out and guide you through all of this. So now, expand your knowledge by exploring page number 1. You have to focus on the topics gravity, understanding gravity, gravity and weight, and of course, falling for gravity. Most of the information was already presented in this first part of the video. So this is just to expand. This is just for you to clarify any doubt that you might have regarding any of the things we have discussed so far. But it's important that you read this part specifically in part number 1, in page number 1, and you add the information to your summary. Right, now we're going to analyze some problems. So it says, a rock dropped from the top of a cliff picks up a speed as it falls. Pretend that a speedometer and odometer are attached to the rock to show readings of speed and distance at 1-second intervals. Both speed and distance are 0 at the time, equals 0. See sketch. Note that after falling 1 second, the speed reading is 10 meters per second. And the distance fallen is 5 meters, I'm sorry. The readings for successive seconds of fall are not shown and are left for you to complete. So draw the composition of the speedometer pointer and write in the correct odometer reading for each time. Use gravity equals 10 meters per second squared and neglect air resistance. Okay. So just to summarize this, we have to analyze how much it speeds up. We have to analyze what happens after each second passes. And our initial speed will be of 0. Keeping in mind that the gravity we're going to use is not 9.8 or 9.81. In this case, will be 10 meters per second square. So right here we have a couple of stated problems that we have to complete. So the speedometer reading increases by the same amount, meters per second, each second. This increase in speed per second is called. Letter B. The distance fallen increases as the square of the. And letter C. If it takes 7 seconds for the rock to reach the ground, then its speed at impact is meters per second. The total distance fallen is in meters, and its acceleration of fall just before impact is, and we have it right there. Okay, now we're going to complete each one of the ones that we have right here. What are the results? How do we find the results for this last question? There are some parts in which you need to apply some formulas. There are some others in which you don't have to. So take into consideration the next formulas. So we have the formula for velocity, and it equals gravity times time. We also have a formula for distance, which will equal 1/2 times gravity times time squared. And taking into considerations the givens that we had in the previous section, in order to find the speed of the, or most likely the velocity of the object that we had in the previous problem, we will substitute gravity as it is in the problem for 10 meters per second square, and we will substitute time, which will be 7 seconds. So what is the resulting velocity? The resulting velocity will be 70 meters per second. Alright, now let's apply it to the formula of distance. We have 1/2, we multiply that by gravity, which we already mentioned, 10 meters per second square. And we're going to multiply that by time square, which will be 7 seconds square. The result for that will be 245 meters. So this is the answer for letter A in the previous section. So the speedometer reading increases by the same amount, which is 10 meters per second each second. This increase in speed per second is called acceleration. So remember that this 10 meters per second is the acceleration that gravity has upon objects when they free fall from somewhere. The distance fallen increases as the square of the time. Remember, the value for gravity is 10 meters per second squared. So every time 1 second goes by, then it is going to double the distance, okay? And if it takes 7 seconds for the rock to reach the ground, then its speed at impact is 70 meters per second. We found the velocity or the speed of impact with the formula that we used right at the top. The total distance fallen is 245 meters. And its acceleration of fall just before impact is 10 meters per second squared. So the acceleration does not change because it is one more time the acceleration of gravity. Alright, now we have some very important information. Please go to page number 3 and make a compilation with all of the formulas that you find in there. So all of these formulas are going to help you to solve all of the problems that we are going to encounter later on. And it's very important that you have a compilation with all of the formulas so you can go back to them whenever you want to solve another problem related to it. Right, so go ahead, you can go, and once you are done with that, you can come back here and we can analyze some problems as well. So welcome back. Now we're going to analyze some exercises. So little baby bird is in a nest that is up in a big oak tree. Mama bird flies back to hungry little baby bird with a fat, juicy worm. In his haste, a little baby bird drops the worm and sadly watches it fall to the ground below in 0.83 seconds. So how high is the nest? Neglect the effect of air resistance. How fast is the worm traveling when it hits the ground? Neglect the effect of air resistance. Alright, so let's go with the first one. So in the first one, they are asking us about how high it is, or most likely what is the distance that it covered. So let's analyze the givens that we have at first. We have our time, which is 0.83 seconds. We have our gravity, which in this case will be minus 9.81 meters per second square because it is going down. And if you remember the exercises that we had related to graphics, then gravity, it will go in the y-axis going downwards, which will be negative. And of course, they are asking for our distance covered. So right here we have the formula for the distance, which is 1/2 times gravity times time square. Once we substitute the values in there, we are going to find out that it covered minus 3.38 meters, right? Because we neglect the air resistance from the problem. Later on, if we analyze air resistance, then the values are going to change. Now, the next one is asking us about the velocity. So we already have the givens, we have time, and we have gravity. So what formula can we use to find the final velocity for this? We can use gravity times time. It is very simple, so we just multiply gravity times time, and we are going to find out that the final velocity will be of minus 8.1 meters per second. One more time, it is negative because of the direction in which it is heading to. Alright, we have another one. The Washington Monument in our nation's capital is 555 feet high. So if 1 meter equals 3.28 feet, what is the height of the Washington Monument in meters? Also, we have neglect the effects of air resistance. How long will it take a penny dropped from the rest of fall from the top of the monument to the ground below? Neglect the effects of air resistance as well. What will be the speed of the penny as it hits the ground? Okay, so now let's go first with the conversion they are asking us for. So we have to turn 555 feet into meters. So using the values that we were given of 3.28 feet equals 1 meter, and of course remembering the way we convert units from one to another, we will get a result of 169 meters as the height of the Washington Monument. Right, what will be the distance that it covered? Well, it covered minus 169.207 meters. We also have our gravity, which will be minus 9.81 meters per second square. And remember that the second question is asking us how long did it take the penny to reach the ground? So we have the formula right here for time, and the formula for time is the square root of 2 times the distance divided by gravity. Right, we substitute the values and we find out that the result is 5.8734 seconds. So our time will be 5.87 seconds. And let's go with the last one. They were asking us about the final velocity. So we know that in order to find the final velocity, we can multiply gravity times the time. We already have our givens for gravity and for time. So we substitute both values and we find out that the final velocity is of minus 57.6 meters per second. So the problems of application are usually very simple. You only need to take into consideration what are the givens that you have, what is the value that you are looking for in the problem, and what formula can adapt to better to find those specific values that you are looking for. All right. So now let's jump to your evaluation. Your students have to read and summarize topic 2.10. Complete any exercises that are missing. We already completed some exercises. We analyzed what formulas we had to use and how to rearrange the problems in order to understand the problems of application better. But there are some missing in topic 2.10. So make sure to complete them once you go there. Right after, they have to complete the lab report on topic 2.10 and then submit it to the evaluation of this topic. Make sure to look for your lab report at the end of the topic and upload it, of course, to Agilex. Students have to upload a compilation of all the summaries they have done during the unit. So please create only one Word document and copy all of the summaries that you have done so far. You have to upload these summaries to Google Classroom because that will substitute the 5 points that we had originally for the notebook. Right, so that was it for today's class. It was a little bit longer, but I consider it was necessary so we could actually understand everything clearly. And of course, it will help you out with your evaluation and report for today. So thank you for coming one more time, guys. I will be seeing you next week. Goodbye.